Hello everyone, welcome to this tutorial. In this tutorial, we are going to create a vision agent using segment editing. The task of vision agent is to use natural language to perform segmentation. It is called grounding SAM. Before moving into the implementation using code, first we review its official research paper. Let's go to research paper. In this section, we will take a look at the official research paper that introduced grounded SAM to understand what this technology actually does and how it works. Don't worry, I will keep it simple and focus on the big picture rather than getting lost in technical details. Let's open its research paper. So, it's called Grounded SAM, assembling open world models for diverse visual tasks. So, what is Grounded SAM? The researcher created this system by combining two existing AI models. Think of it like combining two specialized tools to create something more powerful. They took a model called Grounding DINO, which is really good at finding objects in images when you describe them with uh, text, and they combine it with another model called SAM, which stand for segment editing. Here is the cool part. When you combine these two models, you will get something that can find objects and create precision outlines around them, all based on simple text description that you type in. So instead of having to click on objects or draw on boxes around them manually, you can just tell the system find the dogs or segment the card, and it does all the works for you. So how does the system work? The the researcher designed grounded SAM to solve really challenging problem in computer vision. They realized that trying to segment object directly from text description is incredibly uh, difficult because you need massive amount of high quality training data. So they came up with a clever two-step approach. First First, they use grounding DINO to detect object based on text prompt. This model scans the entire image and draws bounding boxes around anything that matches your description. Then they pass these detected boxes to SAM model, which create precision level mask around each detected object. It's like having one expert find the objects and another expert trace perfect outlines around them. What makes this approach special? Uh, what really impressed me about this research is how the author designed the system to work with other AI models. Uh, they didn't just create an isolated tools. They built something that can connect with others vision system to accomplish much more complex tasks. For example, they showed you to combine grounded SAM with image generation model for precision image editing, or with captioning model like blip to automatically annotate entire image. The performance result they achieve are pretty remarkable. Like you can see the result of grounded SAM. As you can see, if you just input the description, it will segment that part of image. Like here you can see it's segmenting Iron Man. Here you can see it's segmenting insect. Here you can see it's segmenting a flower only on description. uh, and here you can see it segmenting puppies and carpet. So the this model is highly effective in segmentation and also greatly reduce our segmentation load with greater efficiency. So you can also add some more models on it, uh, grounded SAM-SD for highly controlled image editing. It had detected the left eye of the cat, and added something new to it. Like this, you can see grounded SAM OSX, it's detect the human, segment it, and create a 3D pose of human in its plates. Uh, as you can see, grounded SAM performance results are pretty much good on a challenging benchmark called seg in W, which uh, which tests segmentation in real world scenarios. Their systems achieve a 48.7 mean average precision score without any specific training on that data set. That's what we call zero shot performance. The model perform very well on task. It was never specifically trained for it. So it's uh, it's very uh, great for practitioner of computer vision. So what makes grounded and particularly valuable is that it's open vocabulary segmentation to anyone who can type a text description. You don't need to be a computer vision expert or spend time manually annotating training data. You just describe what you want to segment, and the system handles the rest. This research paper demonstrates that sometimes the best innovation comes not from building everything from scratch, but thoughtfully combining existing tools in new way. So with this, our review on research paper is over. Let's get to its code implementation. Now, let's come to its code implementation. First, we will check which GPU I am using NVIDIA L4 GPU, as you can see. Now let's set up the environment. I am going to install some important libraries for this vision agent, which is OpenCV, PlotPy, Matplotlib, NumPy, Torque, and Transformers. Which version is this? As you can see, let's install it. As I have installed it, I will import these libraries. Now, I imported these libraries in our environment. Now, our first task is to uh, the result which we get from Grounded Dino to be in organized manner. So we created some classes like bounding box. This will store the values of bounding boxes as a class. You can see this first one is x mean, x max, y max. It will be in organized manner, so which makes our retrieval easier. Also, we will create a class for detection result, which will store the values like score, label, box, mask, etc. This will make retrieval of other data is also easy for our vision agent. Let's run this. Now I'm going to create some plot utilities like from the result I'm going to annotate that result on image. So I have created a function called annotate, which will as you can see, put rectangle boxes on the image, targeting the object, and also put the text on it, and provide us with the return value of the image which is annotated. As you can also to uh, to plot that detection and also save that, I have created this function plot detection, which will annotate use the previously created function on the annotated and show us in the notebook cell. Let's run this. After that, to show segmentation masks in various color, we have to generate various colors. So this function has a duty to generate various colors for segmentation mark from this data set, as you can see. And another is to also another function is this plot detection plot. It's a UI based plot detection libraries, which makes interaction with image more beautiful. So I with this you can see the result more clearly and understand what object it has detected and what segmentation it has performed. Let's run this now. This function has a duty to convert mask to polygon. The segmentation which we have generated will be converted to polygon format, means it will generate an outline of the mask which will make our target object segmentation more easier. And based on that polygon outline, we will create a more refined mask, which is using this. As you can see, let's run this. Now our most important function to load the image in our environment. This function take the URL as an argument and give uh, download that image from the internet or somewhere else and load it in our environment. Next, this function is to get boxes from detection and store it in a form of list. Let's run this now. This function has the to refine mask, means when the SAM model has generated the segmentation mask, it has to refine in a format which will make visualization more easier. Let's run this. Now, the most important part of our vision agent. First, we have to detect our objects using grounding dino. So we create a detect function which uses grounding dino uh, using the labels which provided by us. Like you can see, it has using the idea research grounding dino tiny and labels which we have given to it to perform detection on images and give us result. And let's run this now. On the given result, we have to perform segmentation, as you can see. So this function takes the detection result as an argument, also the image, and the segment ID means the segmentation model which you are using, and perform segmentation and providing us with the detection result. As you can see now, this function combines the both into a singular function like detection and segment, and that detection is displayed on the image. As you can see, the sorry this the detection is returned as an image and detection result. Let's run this code now. Let's inference uh, our vision agent. First, we load image using URL. As you can see, I am using a image of a plane for my example. I have provided with it a label called airplane. Our threshold is 0.3, and I have provided with a model which I am using, which is grounding dino and SAM VIT base. Let's run this. Now I am using grounded segmentation and provided with the image URL, labels, threshold, refinement is true, detector ID and segmented ID. So the model is performing its task. It has performed its task. Let's plot the detection. As you can see, it is showing us the outline of the object it has detected. As you can see, it has done a great job in detection and performing outline of the object. Let's perform segmentation on it. Using the previous segmentation outline, it has created a mask on the object, as you can see, which is very good and highly accurate for that level of model. So let's perform this in a sequence manner. I have created a function which combine all of these steps in a single step, so we can perform this inference on various other image. Let's run this code now. Load our image. Now I'm using a image of two elephant. Let's perform grounded SAM on it. I'm giving it the URL and the label called elephant. Let's see what happens. The model is working. Hmm. It has detected two elephant and outlined that elephant using grounding dino. And in our next step, you can see it has created a mask over it. Our first detection is this object, which is in a great outline mask using grounded SAM. And other one is this, which is also correct. Let's inference our uh, model on other image like two shapes. Like as you can see, this is two shapes in grassland. Let's similarly perform vision agent on it. As you can see, it has done the same task on it. You only on description of shape and the image provided to it, and has performed segmentation, uh, which is quite nice and accurate. Let's uh, perform multiple of types of object detection. As you can see, this object contains sheep and dog. So I have given it the URL of the image and the labels called sheep and dog. Let's perform inference. As you can see, it has detected all the objects correctly and outlined it. And the segmentation mask is this. It has detected dog two times, which is the downside of that vision agent, but the segmentation mask is accurate on board, so we can check it later. So with this, our tutorial on vision agent using segment anything is over. To read more about this vision agent, you can check our blog on our website where I have explained it in more detail how you can create your segmentation vision agent in very easy steps. Please check our blog on it.